So in this video we're going to look at the potentiometer, and basically this is our potentiometer here, and what we're going to try and do is we're going to read in an analog value from that potentiometer. So basically a scalable value that is changing as we kind of twist the head of the potentiometer. Okay, so there's three connections to be made from this. One of the connection has to go to ground and the other has to go to your supply voltage. Okay, so the two outside pins will go between ground and your supply voltage. Okay, so ground and then supply voltage, and the one in the middle is going to be your variable or your analog signal, basically your variable resistance. Now this is a 10k pot, and we should be able to see that on the back. So it's a 10k pot. So the maximum amount of resistance will be 10 kilo ohms and all the way down to 0 kilo ohms. So that's kind of scalable. If we're taking the V out from the embed, so that's 3.3 volts, it'll be basically proportional from 0 up to 3.3 volts on a kind of linear scale. Basically, you know, that's what we're getting out from that middle pin. Okay, so when we're wiring that up, I basically have it set up here, and you'll see I can kind of join this in, hopefully nice and neatly. So I'll pop that in like that. So on one of the legs, the outer leg is going to ground, straight down to ground here. Then we're just kind of bridging it across and up to 3.3 volts. And then we're taking the middle leg of the potentiometer, it's coming over to one of our analog input pins. And then basically what we're going to do is, we've got the code, and we're going to trigger on an LED. So let me just pop that in, negative leg, or something like that there, negative leg down to ground. And then what we're doing is, in the code we are changing our pulse width modulation duty cycle. Okay, so we're familiar with the pulse width modulation from our servo motors. So we're basically changing that. So I'm just going into one of my pulse width modulation pins here, and we're basically changing that based on the scale of the potentiometer. So you'll see here, and hopefully we can see it as best as possible. Basically what's going to happen is there's going to be a different pulse width signal going into the LED, and as I turn this down, it should start to get dimmer and dimmer. You can see it getting dimmer there. So as I'm turning it, there's a greater pulse width modulation signal I'm going into it, so greater duty cycle. So remember, duty cycle is the ratio between the pulse width and the period, and as I increase that, that's basically being represented in the code so that we can dim and brighten the LED.